Hello, my name is Max, and not that long ago I posted about how I was playing a little bit with sign distance fields. For those not familiar, sign distance fields or SDFs are a way to represent geometry without using polygons. So kind of like the functional representation of 3D graphics, if you will, like representing objects using uh, implicit functions. Not that long ago, Mike Turitzin posted a video about how he was making a game engine based on SDFs. I saw the video like many people, and I thought it was pretty fascinating because sign distance fields have been used pretty intensely in the demo scene to make all kinds of cool stuff, but there hasn't been that much use as part of game engines. But there's a lot of like very appealing properties to SDFs. I think one of the interesting properties that Mike is leveraging as part of his game engine is that it's very easy to modify the world as it's running, kind of like um, yeah, like he can create tunnels and holes throughout objects dynamically and that kind of stuff, which you don't see in like traditional game engines very much. Um, and also you can have like really nice curved surfaces without using a lot of polygons. I mean, I guess like polygon count limitations are not as big of a deal nowadays. But I still feel like SDFs are cool because you can use them to very easily implement like ray tracing techniques and get a lot of the elegance uh, that comes from ray tracing and produce some effects that are much harder to do with polygons or like with a bit less complexity. Um, so when I saw his video, it got me wondering like how hard would it be for me to implement something like that. In his video, Mike goes over how he's using like 3D textures and he's got a brick map, so like a multi-layered 3D grid, and he's caching the SDFs at the corner of the grid cells, I believe, and then he's interpolating that. And I thought it's a very impressive demo. Like it's very impressive what he's built. However, like because he's caching at the corners, like it creates like rounded edges. Like I think his game engine maybe like struggles a little bit more with like sharp corners. I've been wondering if I could use SDF to build something more like the games that I grew up with. You know, like I grew up with Quake 2 and I guess like Unreal Tournament, like Quake 2, Quake 3, Unreal Tournament, Half Life, and those games are based on a world that's built using what's called brushes, and they have a lot of like sharp corners. Anyway, so I'll show you. Like I've been working on a little prototype. This is very much a toy at this point. Currently going with the name Tinkerfield. Might change the name if I find a better one. Um, but yeah, so I start my program, and all that I have in the world is like a floor brush, and I can kind of like float around, uh, go high up in the sky. Um, yeah, and this brush is just a thin surface that's represented using an STF. Like it's basically a flat box. I don't have textures yet, but I can add objects. I can spawn some cubes if I press the O on my keyboard. I can spawn some cubes. These are also represented using SDFs, and I can also subtract. Like if I press P, it subtracts a cylinder, and I can make a hole in my objects, like turn them into Swiss cheese. I can also make holes in the floor. Um, yeah, this is running on a Mac M1 GPU, which is by no means cutting edge, and you should be able to see the frame rate in the bottom left corner. Um, there there's a very real limit to how many objects you can render on a Mac M1 GPU using like SDFs. If you do it completely naively, like I benchmarked it, and at a resolution of 800 by 600, I could render up to like 30 objects, which 30 objects doesn't make for like a very interesting world. So my question was like, how can I scale this? And I came up with like a very simple solution to scale it, which is to just use a spatial grid, right? Like I mean, this technique is already like very well known. Um, so basically, like I built a grid that surrounds the world, and for each grid cell, I can store like is this cell empty or otherwise like store a list of objects that overlap with the cell. And I'll just demo quickly. Like I'm gonna add like a shitload of cubes. Um, like as you can see, like it scales pretty well. Like I can still get a frame rate like 60 frames per second is like a nice smooth frame rate. Uh, I'm still like easily over 100 frames per second with 129 objects. I can keep adding them. The nice thing with this paradigm is like you're largely limited by how much objects you have in just one cell. So like right now my world is split into cells that are like 1 meter by 1 meter by 1 meter cubed. Um, and if I start to like subtract a bunch of cylinders like in a very small amount of space, then you can see the frame rate drop. Like as I turn this cube into Swiss cheese, uh, that's where you hit like the real limitations. Like if there's a lot of objects in a very small volume of space, then the frame rate drops. But if I move away and they occupy less of the visual field, you can see like the frame rate is like immediately going back up. So it's the real limitation here is density as opposed to like the total number of objects that you have. So this is the nice thing with this solution is like I think it's a lot simpler than what Mike has. The downside obviously is um like it probably doesn't scale as much. Like I think with Mike with his 3D textures, he can probably have like very 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 big worlds. With this, I'm probably it's like my world can probably be up to like 512 meters by 500 by 512 by 512, or like maybe like a kilometer wide by a kilometer wide by like 100 meters or something before I'm going to start to run into like GPU memory issues. But I think it's still enough to make like a pretty big game world. And yeah, like I said, like the main advantages would be this is very simple. Like it's like 2,000 lines of code maybe, and also I can have objects that have very sharp corners because I don't need to approximate the rendering of these SDFs using caching. Like I'm directly sampling the SDFs. Um, anyway, so this like I said, this is like a toy prototype. But what I would like to do with this is like, well, first of all, I'll probably add some texturing because right now it's like everything has some very basic like diffuse lighting with like specular highlight. But it'd be nice to have different materials. It'd be nice to have some textures. I also need to come up with some better controls for adding objects. Like right now, I can spawn cubes. I can subtract a cylinder. Like I can add a sphere or something. Um, but I'd like to be able to build worlds with this, like create some walls and things like that. And so that means like I need some keyboard and mouse shortcuts to be able to change the size of cubes and like change their orientation and like select a material. Um, which I think the user interface part of the world editing is actually not non-trivial. Like right now, I have an idea for how to do it like pretty simply with like a bunch of keyboard shortcuts, which I think is gonna work okay. Uh, but there's actually like a UI challenge to like how to design controls to edit a world that you are a part of. Um, yeah, and I'd like to make some kind of a construction game with this, so you can kind of like run around the world and kind of like build a map, build stuff. And my plan is to open source it. Yeah, I want to make this open source and basically just like uh, provide kind of a template, right? It like just show it is possible to build a game engine that uses signed distance fields for graphics, and that can run at an interactive frame rate that can support like a good number of objects, like enough to build like an interesting world. And the code doesn't have to be super complicated. Like I said, it's like I'm just using a really dumb spatial grid here, and it's performing pretty fast on a Mac M1 GPU. Like the Mac M1 GPU is something like 10 times less performance than uh like a low to mid end modern Nvidia gaming GPU. So uh, if it can run this fast on an M1 GPU with like not that much optimization effort, then I think on a modern GPU this is gonna be like real fast. Um, Yeah, I guess one final note, like I've said, like I'm just using a spatial grid right now. I've also looked at using an octree. Um, part of this code is AI generated. I mean, I have some experience with like GLSL, but I'm using the WGPU crate, like web GPU for this, which I had no experience with, and having access to like a coding assistant, I've been using Gemini for this, has been very useful. And I was able to prompt it to make an Oxtree implementation, which I briefly tried. Unfortunately, I found the performance of the Octree is like a lot less predictable. Like the beauty of the grid is that the performance is like really smooth, really uniform. It's very easy to understand the implementation. Raymarching an Octree on GPU is at least the implementation that I generated was not did not perform as well. Did not really. Well, my hope with the Octree was that it would scale better to like a large number of objects. But like what I found is it's very easy to run into corner cases where like it generates way too many nodes, does way too much splitting, and the performance is uneven. But I figure after I open source this, like maybe maybe some open source contributors can help me like either optimize this code or yeah, or implement like a better Octree implementation that will perform a lot better than the one that I was able to produce. Yeah, so that's it for my little toy demo. Feel free to be impressed or very unimpressed by this thing. Um, yeah, but I'm pretty happy with it. I think I could demonstrate that it's possible to build some interesting worlds even with this really simple SDF game engine. And yeah, and I'm hoping that's gonna inspire uh, other people too. Like you totally can create a game that doesn't use any polygons for rendering. Yeah. So thanks for your time. That's it for my little demo.